My name is Nancy McMillan. I am a professor of geology and I'm the department head of the Department of Geological Sciences here at NMSU. Well, before I was interested in LIBS, I was an igneous petrologist. I still am an igneous petrologist, but my main interest was igneous petrology, which is understanding igneous or volcanic rocks. And I had a grant from the National Science Foundation to analyze the geochemical composition of volcanic rocks in southern New Mexico. And the point was to understand how the Rio Grande Rift got started. And a big part of that story is the volcanic rocks in the Potrillo volcanic field.
So I'm Emily Johnson, and I'm a professor in the Department of Geological Sciences. So I broadly study volcanoes, mainly ancient volcanoes that are no longer erupting. And what I'm interested in is trying to figure out what the magmas that produced the eruption did before the eruption started. So where the magmas came from, and what the eruption may have been like. Yeah, so I've been interested in small basaltic eruptions, which are like those in the Potrillo volcanic field. So basalts are the magma type that erupts in Hawaii, for example. And part of the reason I'm interested in the Potrillos is it's some of the youngest volcanic eruptions in southern New Mexico. So the eruptions there are as old as about 2 million years and maybe as young as about 14,000 years.
So I guess the other thing about volcanoes in New Mexico is there's a magma chamber underneath Socorro. So that's a zone of melt that's in the crust. And we can tell it's there using geophysical methods, and it hasn't erupted yet, but someday it might. Now, chances are it's not going to be a dangerous eruption like Pinatubo or Mount St. Helens. It'll probably be a basalt flow that comes up, finds a stream, and runs down the stream and makes a couple of really cool looking lava flows. But we can hope. We can hope that it's going to happen. So the Potrillo volcanic field is important because it's young. So it tells us basically what's going on now. Now, when a geology says now, we mean like the last million years, not this week. But it tells us what's going on now. And the analysis of the Potrillo volcanic field rocks tells us that those magmas are melted from a part of the earth called the asthenosphere. So that's the mantle that is pretty deep. But the asthenosphere is kind of gushy. It's not really solid rock. And so what's happening is that North America is being pulled apart. And when it does, the asthenosphere can move up underneath. And when it moves up, it goes to lower pressure, and that causes it to melt. And by looking, we know that from the chemical composition of those volcanic rocks. So we were able to understand why the melt happened.
I'm Danny Vitarelli. I'm a grad student at the New Mexico State Geological Sciences Department, and basically what I do is I'm studying a volcano southwest of town called Kilburn Hole and just focusing on constraining the eruptive volume and explosion energies so we can look at hazards more or less. So specifically what we do is we go out into the field of this volcano and we have a Trimble GPS, sort of. It's basically just a fancy surveyor's GPS, and we march around the crater of this volcano. We take some elevation measurements, and we compare those to the lower elevation that's exposed within the crater of what we know used to be the surface before the eruption. And for areas where it's not exposed, where we don't know how thick that deposit is, we dig little holes with a big, really tall soil auger and just measure how thick that deposit is all around the volcano so we can basically constrain the change in thickness from the crater out to the more distal areas.
In the Potrillo volcanic field, there are about 100 volcanoes, and most of them are these little cinder cones, these small cone-shaped triangular volcanoes. And Aden and the other cones are all sort of relatively similar in that respect. There are 5 of these Mar volcanoes, these explosive volcanoes like Kilburn, and Kilburn is the largest of those 5. Yeah, and Aden and Kilburn are kind of the two different end members. So Aden is more like Hawaii-style lava oozing across the surface. And the eruption of Aden, which was maybe 20,000 years ago, probably looked like Kilauea when it erupts today. Large channels of basaltic lava flowing across Earth's surface and gradually cooling. Kilburn, on the other hand, which we don't know exactly when it erupted, but it could be as young as 14,000 years ago, was a very explosive eruption. And so when that rising magma interacted with the groundwater, that flashes the groundwater's steam and causes this big eruption that's explosive. So instead of lava oozing across the surface, there were no lava flows at Kilburn. It was explosive and created lots of ash, and probably a column of ash that rose into the sky, and then ash clouds that traveled across Earth's surface. So a very different and more hazardous type of eruption. I was amazed at how big the crater is. So this Kilburn Hole is a specific type of volcanic crater where rising hot magma interacts with groundwater and explodes. And so it blasts out this really large ejection crater. And I've seen other volcanoes like this, they're called Mar volcanoes. And I've seen several of these before, but never one that's so large. So that was really exciting, and I was amazed at how big the crater was. The other really cool thing about Kilburn that I was amazed at is the abundance of these mantle xenoliths, these blocks of the mantle rock that the magma brought up to the surface. And these beautiful green crystalline rocks are located all around the crater rim. Yeah, and I think everyone's always impressed with the size of the crater at Kilburn. And I think, the deposits are really interesting too. They're these really white ashy deposits. They're not usually, like if you think about a volcano, you think about these black lava flows, for example, and these look really different. So that part I think everyone is always surprised by, is how unique the deposits look. And everyone's always amazed at these xenoliths, these chunks of green mantle rock. And so these are bits of rock that came from 35 kilometers depth and are now sitting at Earth's surface. And it's pretty amazing and unique to be able to hold a piece of deep earth in your hand. And all the students really like that too.
It's hot, really sandy, and I was like, this is a volcano. It doesn't look like a volcano when you get out there. It's a lot of just ashy, very thin deposits. So when you're looking at it, it's not what you think of a volcano. There's not really any lava associated with it. So when I first got there, I was like, I'm gonna work on this for 2 years. This is a hole in the ground. But after spending a lot of time with Kilburn, I've grown to love the volcano. It's a little different, it's a little funky, but it's definitely interesting, and we don't know that much about it, which is kind of cool.
Well, going way back, I grew up in New Mexico, so yes, volcanoes are cool. I was an undergraduate here at NMSU, and when I took intro geology, I decided I was going to get a PhD and study volcanoes just like Dr. Seeger, and basically that's what happened. I even got a job back here with Dr. Seeger, who was my mentor when I was an undergraduate, so that was pretty exciting. But for this grant, I was really interested in tracking which parts of the Earth were melting at what time. And so melting can happen. In order to melt, rocks have to get hot. And so that can happen really deep in the Earth, like 125 miles deep, or shallower in the Earth, say like 10 to 20 miles deep. And by analyzing the chemical composition of rocks, we can understand what parts of the Earth were melting. And if we know the age of the rocks, we know when that melting was happening. And then using all of that information, we can think about what plate tectonic forces were going on at the time.
Why Kilburn? Well, so it's a Mar volcano, which is just a fancy way of saying it's a small volume of magma that interacted with groundwater before it erupted. And so they're pretty common in the geologic record, but it's not that they haven't studied them, they're just difficult to study because they're usually not preserved very well. So there's not a whole lot of information on specific processes that form these or how they change throughout their eruptive lifetime. And there's a couple different models of how they form, and nobody can really seem to agree on one. So there's a lot of research to be done on Mar volcanoes, and even though Kilburn's not actively erupting, what we learn from Kilburn can hopefully inform us about other Mars or other volcanic fields that could potentially have Mars so that you could assess what kind of hazards are associated with them.
When I was a little kid, I loved dinosaurs, but it was actually an episode of a program called Reading Rainbow with LeVar Burton, where they went to Kilauea, and Kilauea had just started erupting, and so Kilauea volcano in Hawaii started erupting in, I think, 1981, and erupted all the way through last year until the eruption finally stopped. So it erupted for a really long time. So he flew to Hawaii and was standing in front of this fire fountain with lava spewing in the background, and he was interviewing a volcanologist about the eruption. And they read a book called Hill of Fire. That was the Reading Rainbow book for that episode, and it was about this little cinder cone volcano that came up in a cornfield in Mexico in 1943. So that was a true story, and I just remember being totally amazed about volcanism and volcanoes. Kind of forgot about all that stuff for a long time until I took a geology course as an undergrad by the time I was at University of Michigan. And I just took the geology class because I remember, thinking dinosaurs and volcanoes were cool as a kid, and ended up just falling in love and switching my major. And interestingly, I ended up going to do my PhD in Mexico on that volcano that erupted in a cornfield that I read about as like a 5-year-old kid on Reading Rainbow. So.
Well, the first time I set foot in the Petrillo volcanic field was when I was an undergraduate here at NMSU, and so I was in my late teens, and I went to a volcano called Aden Volcano, and I fell in love. Oh, Aden Crater is an amazing place. You can see places where when the lava lake cooled, you can see cracks where it cooled and contracted. So like how pumpkin pies sometimes get those cracks in them.
Yeah.
You can see that in the lavas. There's a fault in the middle of the volcano where half of the lava lake collapsed and half of it didn't collapse. There is a fumarole on one side. A fumarole is a hole in the ground where the volcanic gases are escaping. But years and years ago, a giant sloth was discovered in there, a fossilized giant sloth, and so they were able to date it, and so that they knew that the volcano had to be older than the sloth. So for a long time, that's how we knew the age of Aden Volcano. So when people first discovered the Rio Grande Rift, they thought, oh, North America is going to split, not quite in half, but it's going to split, and eventually there'll be a new ocean, eventually being 35 million years from now. There'll be a new ocean here where New Mexico used to be. It turns out that the Rio Grande Rift is not really going that strong. It's not what we call an active rift. It's not really being driven by forces from underneath. It's due to other plate motions, so it's a passive rift.